And now there's one new theorem that we're going to learn, and it says that if two segments with a common endpoint that are exterior to a circle, so the two segments are outside the circle, or their common endpoint is really, you can think of it as their common endpoint is outside the circle. If those two segments are both tangent to a circle, then the segments must be congruent to each other. So if I look out here and I see that I have segment AB and I have segment AC, and since segment AB and segment PB are perpendicular, it means that this is a tangent. And since segment AC and segment PC are perpendicular, it means this is also a tangent. So these two segments are both tangent to this circle, and they both kind of start at point A. And in that case, segment AB and segment AC would be congruent to each other. So we could kind of, if we wanted to, we could mark those congruent. And that's what this theorem is saying. So let's take a look at one example that kind of puts that idea to use. So in this final example, it asks us what is the perimeter of ABCD. So we got this big quadrilateral right here that we have to find the perimeter of, which means we would need to know how long each side of it is. The only sides that I can tell right away is I can see that BC has a length of 5, right? This thing has a length of 5. And then segment AD over here has a length of 13, just by adding the 7 and the 6 and the 2 and the 3. What I don't know is anything about segment AB or segment CD. But in the picture, I notice that from point A, I have this segment that goes out to this point. Let's label that point as point E, all right? And segment AE is perpendicular to this radius. Well, that would mean that it's a tangent. And then I have this point right here where segment A, let's call that point F. So segment AF is also perpendicular to a radius, and so that would mean that segment AF is also a tangent. So I have these two tangent segments coming out from A, one going over here to E, one going over here to F. These two segments would have to be congruent. If this one's 7, this one over here would also need to be 7. And I can kind of see that same idea repeating itself on all these corners. Let's label a few of these other points. Let's call that point G, and let's call this point H. I notice that segment BG is a tangent to the circle, because if this is a 90-degree angle, so is this one, right? So BG is a tangent, and then BE is also a tangent for the same reason. If this is 90, then this is 90, and then I have that radius coming out to my segment and making a 90-degree angle. Makes it a tangent. So BG and BE would both have the length of 2. They would have to be congruent to each other. And now I see that segment AB has a length of 9. Over here on this side, I can see that CH and CG, they're both tangents, so they would have to have the same length. So segment CH is 3. And then here I have DF and DH, two tangents again, because these would have to be 90-degree angles. And then I'd have segment DF perpendicular to a radius, segment DH would be perpendicular to a radius, so they're both going to be tangents. They're both coming from point D, so they have to be congruent to each other. So that's going to be a 6, and this would have a length of 9. So the perimeter of segment AD is going to be 9 plus 5 plus 9 plus 13, and that's going to give me, let's see, that'd be 14 plus 22, so that would give me a total of 36 for the perimeter.